All right, so welcome back. Today in this video, we're going to be continuing our geotechnical engineering section of the Civil FE exam review, and we're going to be looking at effective stress. So I have a few practice problems for you all that I want to go through. These are not super complicated, but they will bring into effect some of the concepts that they're going to be wanting you to be able to know and understand on your exam. So let's go ahead and get into it. All right, so number one says, based on the following information, what is the effective stress of the soil? So your total stress is equal to 150 kPa and your pore water pressure is equal to 30 kPa. So what information do they give us? Well, they give us the total stress. And they give us the pore water pressure. Okay, and we're asked to find the effective stress. All right, so I'm going to look up and search effective stress. That's what we're trying to find. All right, when I do that, three things come up. All right, effective stress. This is actually in the geotech section. So it says effective stress is equal to this symbol prime. I think that's normal stress minus stress minus U. Okay, so what do these symbols mean? Because we don't know what the symbols mean, it's not very helpful to us. Okay, so see if they tell us what those symbols mean somewhere. Oh, it does not. Oh. So total vertical stress, effective vertical stress. So total stress is going to be your regular, I think it's sigma, or I don't know that symbol. I'm going to call it sigma. But that symbol is your total stress. Now your effective stress is going to be that symbol prime. Okay, so I'll just write that out for us. This symbol is going to be total stress. All right, this symbol that has the prime in front of it is going to be your effective stress. All right, what about U? U is the pore water pressure. So U pore water pressure. Kind of had to go hunting and digging for that. All right, so going back to our equation. So so this is saying effective stress is equal to total stress minus pore pressure. Okay, so do I have total stress? Yes. Do I have water pressure? Pore water pressure? Yes. So we know that we can solve for this now. So the formula we need is sigma prime minus is equal to sigma minus U. Okay, where sigma prime is equal to was sigma or total stress, so 150 kPa, and then minus our pore water pressure, right? That's U, minus 30. And so when we solve that, we get 120 kPa or D. All right, pretty straightforward. You just need to know what the symbols mean, right? Number 2, what is the pressure head of the soil in meters if the pore pressure is 50 kPa? Okay. So what information are we given? We're given the pore pressure, right? Given pore pressure, we're trying to find the pressure head of the soil in meters, right? Any formulas that we might need when we're trying to find pressure head. So I'm going to search pressure head. Okay, so I think we're already maybe in the right spot. So HU is pressure head. Okay, I think that's what we need. We're trying to solve for. We have the unit weight of water. Do we know the unit weight of water? They give that to us somewhere. Unit weight of water. 9.81 kilonewtons per meter cubed. Okay, and then what was the last thing? Pressure head. Okay, so yeah, that was everything. So the formula we need is U is equal to HU times Y sub W. Okay. What is U? U is our pore pressure. So how do I know that? Well, it tells us that pore water pressure is defined as by U. Okay. All right. So we know that. I'm just gonna write out my variables just so you know. So U is equal to 50 kPa. HU is the pressure head, right here, which is question mark because that's what we're solving for. And then unit weight of water is equal to 9.81 kilonewtons per meter cubed, right? And so where did I get that? I just scrolled up to the top of the geotech section, and it tells us that the unit, this is basically saying the unit weight of water, which is not going to change, is either 62.4 pounds per foot cubed or 9.81 kilonewtons per meter cubed. And so I know since our answer needs to be in meters. I know I'm dealing with my SI units. All right. Okay. Just want to make sure that you're able to follow along with everything that I'm doing. This stuff can get confusing. Okay, so now we have U divided by the unit weight of water is equal to HU, which is what we need, right? So now we can just say 50 kPa divided by 9.81 kilonewtons per meter cubed is equal to HU. But there's a problem, right? If we want our answer to land in meters, we need to make sure that our units are actually correct, right? So there's one thing that we need to understand when it comes to units. So so we have kilopascals and then we have kilonewtons over meters cubed. So how do we can we get one of these units to cancel, right? And let's go to our unit conversions, because that's where it tells us if these units can be converted to match, right? So the one thing you want to pay attention to, and just remember for yourself, is that 1 Pascal is equal to 1 Newton per meter squared, right? So if I have, let's just do this conversion. If I have 50 kPa, right? I know that 1 kPa is going to equal 1 kilonewton per meter squared. Right? Or you could say, if I know that 1 PA is equal to 1 Newton per meter squared, right? Well, if I want to get kilopascals, how would I do that? Well, I would multiply by both sides by 1,000. So 1 kPa would equal 1 kilonewton per meter squared. All right, so hopefully that makes sense. So now if you're substituting this out, you know that 50 kPa is also equal to 50 kilonewtons per meters squared, all over 9.81 kilonewtons per meter cubed. And that's how you cancel your units. And you should be left with 5.09 meters, or C. Okay. Look at number 3. So it says calculate the total stress based on the following information. So we're given pore water pressure and we're given effective stress that is equal to 220 kPa. Okay. So first we want to write out what we're given. We are given pore water pressure and also given effective stress. And they want us to find total stress. All right, so pore water pressure, just searching that to hopefully get me roughly in the right area. Okay, so I know that pore water pressure is going to be the same thing as U. And typically, total stress minus pore total stress minus pore water pressure, U, is equal to my effective stress. So by knowing that, how can I take the information that I have and calculate what I'm looking for, which is total stress? So total stress minus U is equal to effective stress. Right? Okay, I have effective stress. I have pore pressure, so I don't have sigma, which is what I'm trying to solve for, but I do have my pore water pressure, which is 80 kPa, and I know that that is equal to my effective stress, which is 220 kPa. And so then I know that if I add to both sides, then my total stress that solving for is going to be 300 kPa, kilopascals. Pretty, not too difficult. All right, so that concludes the effective stress sections. Main thing is knowing, okay, what is pore water pressure, what is the unit weight of water, what is effective stress, and how they all work together. You can solve pressure head, which we did in some of these examples. So just a few things to keep in mind as you're going through. All right, in the next section, we'll be going through stability of retaining structures.